In this video, I would like to review some of the class exercises we did on January 30th and January the 4th. And I'd start with the 3 additions to the shortcut list that we're adding in Test 2. You can see them at the bottom of the Test 2 Study Checklist draft. It's number 7. And it talks about how to select an empty range adjacent to a non-empty range. And by that, what we mean is if we had a range like this, let's look at 7 cells instead of 1,000. We're trying to select this range, but it's 1,000 cells wide. We need a quick way to get to the end of this range because we know that Control-Shift right arrow takes us way too far to the right. So let's do this. Let's go up, over, down, and then we can Control-Shift left. So if we have a formula in there like this, and we want to copy it, up, over, down, left, paste, then that works just fine. And that's trick number 1 here. I'm going to skip down because trick 3 probably comes the next most logically. And let's say that we had the formula in there, but we forgot to copy it. We just went up, over, down, and to the left. We'd like to copy that formula to the right. We can just hit Control R and it fills it to the right. That's the same as copying this cell and pasting it across those cells. With 7 years here, it doesn't seem to be too important, but with 1,000 up here, it is. So practice that. And now let's go back and pick up this second one, the fill of range cells using Control Enter. And that would be if we didn't have the formula, but we wanted to select the range first. Now I need to get my highlighted cell back to where I want to type the first formula. There are 2 ways I can do that. Control period will take me back and forth, and Enter will move me along the cells. So when we first selected it from right to left, our cursor was left here, so I'll just hit Enter to move our cursor there. Then when I enter the formula that I'd like, I will hold down the Control key before I press Enter, and it fills the entire range at once. So practice those up here, and those will be the 3 ways to do this. The next thing I want to draw your attention to, because I don't think we got there in all the classes, was this color coding. And notice that the colors, the warmer colors apply to the lower cash flow multiples, and the cooler colors apply to the higher cash flow multiples. Because remember, the purpose of this data table was to find what's a likely combination of discount rate and growth rate to result in a certain cash flow multiple. At the beginning of class, we had done a little bidding exercise and found that most of the class was comfortable kind of in the 5 to 10 cash flow multiple range. And that what the table tells us is that 10% was probably too low a discount rate, but 15 or 20 was probably better, particularly depending on what kind of growth rate we expected. So anytime we're doing a data table to see a range of outcomes like that, it's a good time to try that conditional formatting shortcut that you learned for Test 1. And if you just do the Alt-HLS, it will bring you right here. And this is the default. It's the one I'll always use in this class. So the way to do that would be select this, Alt-HLS, Enter. And we get that thing automatically color-coded from low to high. And then finally, please take a look at this Takeaways tab, especially if you missed class, because our lecture had actually a method to the madness where we started with our little bidding exercise, our informal auction. We did a little bit of math to convince ourselves that these perpetuity formulas work. And then we went and looked at the sensitivities to those that we just color-coded. We did all of this so we could get used to what the multiples method really means in terms of predicting future value of cash flows, and what the perpetual growth method really means for doing the same. Now in this file, we use the perpetual growth method as it's shown in most books. The present value is equal to the following cash flow divided by the discount rate minus the growth rate. But since we'll rarely know the following cash flow, we could also use the current cash flow, 1 plus growth rate, times the current cash flow just gives us the next cash flow, and divide it by the same denominator. So let's move to the next file, this class exercise February 4, to look at that. In this file, we warm up a bit with some basic before-tax cash flow models, both horizontal and vertical. And then we move to this perpetual growth model. Much like the previous exercise, we're trying to approximate all of these future cash flows with a terminal value. So let's calculate the future cash flows as the previous times 1 plus the perpetual growth rate. Copy, up, over, down, left, paste. Notice those cash flows get really big after 1,000 years, but they also get highly discounted. We want to know if we can calculate the NPV of them. And since it's only the future cash flows, there's nothing in time 0. I don't have anything before the NPV. So I'm going to take the discount rate and these cash flows to come up with 10,324. Now, to use the terminal value equation in perpetual growth, we're not going to know this cash flow, and we don't want to have to calculate it. So we're going to take the current cash flow times 1 plus the growth rate divided by the discount rate minus the growth rate. So look what we're doing here. Instead of having next year's cash flow in the numerator, we're taking this year's cash flow, inflating it by the perpetual growth rate, just like we would have done to get next year's cash flow, and then dividing it by the discount rate minus the growth rate. We get the same answer for all these future cash flows that we did with the NPV formula, but we don't have to calculate any of the future cash flows. So I colored this tab yellow because it's important to remember. When you come over here and work through the entire problem, it's these cells that will be something that we come back to again and again, where we work very hard to forecast these cash flows, and then we estimate everything else in the future with this one, and then we add them together to get something that we can take the actual value of the firm or the project for. In the next video, we'll move over here and begin talking about the after-tax situation, where we have a tax calculation to come up with our taxes based on a depreciation schedule applied to our investments. These practice problems in the February 4 exercise begin with the basic concept and then talk about how complicated might this depreciation get. For example, if our investments occur at more than one time, or if we have more than one type of investment, maybe one that's depreciated over 5 years and one that's depreciated over 3, then is there any consolidation we can do before this thing gets out of hand, such that every different type of investment we make requires a lot of hard-coded calculation down here? So I think that's a good place to start a new video, and I think I'll call that something like calculating depreciation with some product.